I'm very happy to be here today. I'm Tim Spann, a developer advocate at Stream Native. Today, we're talking about how to do Apache Pulsar development with Python. We're going to keep it intro level, make it easy. If you've never seen Pulsar before, that's fine. One of the coolest things with Pulsar versus some of the other messaging and streaming technologies out there is if you don't know Pulsar, you could call into the Pulsar cluster via other mechanisms that you may know already, things like MQTT, WebSockets, Kafka protocol, REST, lots of other options. So make it easy there. So you can pick up Pulsar slowly, or if you've got a bunch of apps you have already, you can move them to Pulsar without having to change that front end library. Makes it pretty easy. So we'll go in a little bit, what's Pulsar, show you some different things we could do with Python 3 with Pulsar. I'll show you how to make a consumer, someone getting messages, producer, making messages, show you a couple different other libraries out there that you may know already, show you how we use Python for making functions. These are kind of like database triggers for data as it's streaming through the system. And we'll show you how you can make things more record-oriented by using schemas, which is very easy in Python. So I'm, as I mentioned, Tim Spann. I've been really big on what I call the flip or flippin' stack, which is Apache Pulsar, Apache Flink, Apache NiFi, maybe Spark, some other technologies in there. Make it really easy developing streaming apps. And I've been doing this for a couple of years at a couple different companies. And let's just get into it. So where I work is Stream Native. It's a company that helps develop Apache Pulsar and makes it available in a couple different formats, where it's in the cloud or you need it hosted in wherever your own facility is with Kubernetes. I have a newsletter I do every week. It is called Flipstack Weekly, and I've got a lot of cool stuff in there. If you have any questions on that, you can come there, respond to stuff, lots of cool articles and things. Free training. So if you get a little taste of Pulsar, you want to learn a little more, it's very easy to pick it up. You really just have to come here, you get a full environment, and you can start doing stuff with Pulsar, learn it the easy way for free. Why should you use Pulsar? Well, I kind of touched on a couple things there, but a few things that are really awesome is this unified messaging. So what this means is you could use this for any type of messaging. So you have the real-time streaming you're used to with things like Kafka and Kinesis. We can do that. We can do the messaging like in Rabbit or in JMS or any other type of messaging. Whatever your use case is, Pulsar supports all of them. Whether it's a work queue, it's exactly once messaging, whatever you need there. All your messages guaranteed to get there. Very resilient, good architecture there. Designed to be cloud native. So you've got a separation from compute and storage, each scale up independently. And scalability is near infinite. We have some large cloud companies supporting petabytes. You could scale out, scale up. What's nice is tiered out the storage without having to rewrite any code or do anything fancy. All that is part of the open source. So if you're doing things like ActiveMQ or SQS, easily do that with Pulsar. And there's adapters to handle that. There's also connectors. So if you want data to automatically come into Pulsar, but you still want to use a RabbitMQ library, you could do that. Same if you want to do streaming use cases, you know, you're getting data out of CDC, you're looking at real-time events, you want to do an event at a time, maybe exactly once, order matters. We could do that with Pulsar as well. Different ways you get your data, pretty straightforward. But what is Pulsar? You know, it's a lot of different things to different people, but under the covers, it is Pulsar brokers that handle all the routing, make sure the messages get to be where they need to be. Has some caching, but it's stateless. Again, runs well in Kubernetes. Automatically load balances and supports tons of clients. You need to support more clients, spin up another broker. pretty straightforward. Messages are stored in a storage layer managed by Apache Bookkeeper. This is also very scalable and very easy to work with. And then finally, for metadata services, all that kind of coordination, that's handled by a metadata store. That is in the version coming out in a couple of days, completely open. So you could use different metadata stores. Zookeeper has been the default one in the past. This is common with big data, but RocksDB, etcd, and others will be added. If you have your favorite, you could just use the one you have in your environment, and that'll be perfectly fine for a Pulsar cluster. So we want to push messages in. That's pretty much the first thing you want to do, get your messages going. So producers make the messages, they go into a topic, brokers handle, make sure that messages go to the right place. You set up a subscription. This is how you get the different type of messaging. So consumers can decide, I want things in one order. I want just one message, and whoever else is consuming it can get them as well. Pretty straightforward. But what's a message? Made up of a couple different things. You got your data payload. You can call that a value. This is your actual message. This is the event, the record, a file that you want to transmit somewhere. Well, these are raw bytes, but we make them in different formats and have schemas so they can be more intelligent styles of data. Usually have a key, and I highly recommend putting a key on it. Makes it easier to identify, helps in partitioning the data for more performance. And if we need to compact things, make it easier. Properties, sometimes you have some extra data you want to put in there. Some key value pair, maybe it's for your own use, maybe it's for debugging. Maybe that's important data, but you don't want to change the payload, add a property. Producer name lets me know who produced it, helpful to have. Sequence ID lets you know the order of the messages. Again, important if you want it in an exact order. So that's nice. Pulsar is pretty simple messaging system, but you don't want to just have one way to get data in and out. Lots of different ways to connect to Pulsar. I'll show you functions in a little bit. You write them in a couple different languages. Obviously, today we're talking Python. And Python is a first weight language there. You can do a lot of cool stuff with functions. Think of it like a database trigger. I can route things. I could send things to multiple outputs, do transformations, run machine learning, which is a good use case for Python. I can add different connectors. So say I want data to automatically stream to S3 or Cassandra or a database or Mongo or Scylla. I could just use a sync and it'll automatically send it there. I want something to read data for me. I could use a source. It doesn't matter how data gets into Pulsar. I can consume it any way I want. So I can have a Python app produce all my data and then have Java app consume it. A good way to communicate between different languages, different systems, different clouds, different on-prem to cloud, from devices up to the cloud, wherever it needs to be. If you don't want to rewrite some of your existing systems, we support a number of protocol handlers. So it'll look like when you talk to Pulsar that it's something else. So it can be AMQP for things like Rabbit, Kafka protocol, MQTT. Makes it nice so I can have one cluster for all messaging, regardless of what you're doing with it. So I could have all my IoT stuff come in, all my CDC stuff come in, all my local messages, and have different things put together. Maybe have a function combine them. Then maybe do some advanced processing with things like Flink or Spark. And built in, we have Pulsar SQL, which is Presto or Trino. So you could query anything in a topic. So you could use it as like a simple database if you need to. And when your data gets too much for your bookkeeper, or you don't want to pay for that expensive SSD, you can auto tier it out to more inexpensive storage. I still get full access from all the other connectivity, still query it, don't have to change anything. Perhaps it's a little slower because it's not an SSD, it's an S3 or something, but there's slight trade-off there. But now you've got petabytes of storage. So we have a way to handle schemas for you that's built into Pulsar. I don't have to worry about it. I don't have to set up some third-party thing somewhere. When I create a schema, which I can do in a couple lines of Python, I push my messages in, it'll load that schema into the registry the first time. And I can do that with the REST endpoint command line, or just do the code. And it's very easy for me to have a schema in the system, support a bunch of different types like Avro with Json and Produc are the most common. And then when I'm producing data, I make sure it's in that schema. If the schema changes, that can be updated. So the idea that schema goes along with the data so that we have whoever's going to read it knows what format it should be. What's nice is if I use a schema, it'll automatically be acknowledged in Spark SQL, in Flink SQL, and Trino as a table. So it makes my life very easy to get data out. Of course, when you're consuming it with, say, a Python app, I can get that schema as well. Makes it easy, comes in a object. You don't have to worry about parsing some fields or doing some manual labor. It's nice. So we mentioned mop. This is so I can do MQTT, and it just looks like MQTT. Even from an off-the-shelf device, I put in Pulsar and I put in the port I'm running MQTT on, usually 1883. And it just looks like MQTT, and I just send data. Easy. Same thing with Kafka. Turn it on, I can use all the Kafka libraries. What's nice is, doesn't matter what libraries I use to get data in and out. So to people using the system, maybe I only know the Pulsar library, but I don't know the data came from MQTT, came from Kafka, came from a Pulsar IO source. Doesn't matter. You get it in and out any format you want. Pulsar SQL, again, nice, automatically works with that tiered storage, goes as big as the cluster needs to go, makes it very easy and very fast to read your data. This is what's in that topic right now. Now we have ways to get the data out continuously with things like Flink SQL and Spark structured streaming. These will grab an event as it happens. So you can keep a SQL running as events come in, be done. And you can run that with PySpark or with PyFlink or however you want to do it, or with just SQL, whatever is easier for you. Pulsar acts as a really good way to buffer your data, chunk it into batches if you need to, route it somewhere, filter it, aggregate it together, enrich it with other sources, replicate it, say up to different clouds. Geo-replication is built into Pulsar. You don't have to do anything. Just configure who's talking to who and set up what kind of security you want. Security is pretty powerful in Pulsar. You could choose however you want it to be secured. Very easy to set up. I could have Pulsar dedupe my data, decouple these systems. So Python app is running on a Windows box in a closet somewhere, gets the data to Pulsar, and there's some cloud system that's getting it. It's very easy to distribute your data among as many different consumers of that data as it needs to be. And it can be automatic syncs, or it could be code of, multiple different languages wherever it needs to go, or it could tier out automatically to S3. Very easy way for you to get your data wherever it needs to go. Here's an example diagram of some of the apps I'm doing today. I call them Flippy because it sounds cool to me, and it's nice to put that Python in there. And so I've got Python running on NVIDIA, on some Raspberry Pis, on my laptop, in a Jupyter notebook, in a phone, wherever Python's running, and it can push to me any way it wants. There's a native Python library to connect to Pulsar, or I could talk to one of those other protocols, whether it's MQTT, Kafka, or WebSockets, or I could make a REST call. Very easy to push data in. Once it's in, I could do continuous compute with things like Flink, and then the data is available for as many Python apps want to read it, or Spark and Trino and Flink. What's nice is you don't have to have one consumer of the data. If you want it shared out, you can have multiple subscriptions to the data, whoever needs to get the data can get it, and they can get it in the format they need. They need it as SQL, sure. They need it to be transformed in some way, drop in a simple function, which you can write in Python, and that Python can be distributed with what we call function mesh on top of Kubernetes, or it could run locally, lots of options there. And we could have that data stream into some database without having to write any code. So it makes you optimize what you're using your Python for, use it for what it's best at, data engineering, data science, smart logic, machine learning. Here, Pulsar Functions let you run things in a serverless environment, and it's event driven. So an event comes into a topic, it'll trigger your function, and then it can do whatever it needs to do. It's kind of similar to AWS Lambda, but it's all open source, and you run it in your own environment or run it in Stream Natives, wherever you want to run Pulsar, and natively in Python. There's some other languages you could choose as well, like Java or Go. So if you have different developers on your team, they don't all have to do Python, though today they probably should, whichever language they like. So different data comes in from one or more topics into a function, and it can have built-in logging, which it sends to a topic, and then it could send the output out to a topic, or it could send it to multiple topics, or it could stop there. It could do custom codes. You want to drop it to a specialized database, or whatever you want to do. It also can keep state. So if you want to just increment some kind of aggregate values, you could do that. Very common to run machine learning models. So I can run PyTorch and TensorFlow and MXNet, any kind of Python machine learning in there. Vader sentiment, any library you got there, pretty easy to do, and use that to process events as they come through the system. Function mesh makes that a little easier to run it. We've got a Kubernetes system for that, but let's not show 10,000 slides. Let's get into some code. Now I'll go into my live environment, but I have in the slides all the steps you need to do, and well as links to GitHub repositories, into whatever you may need there to make it easy. So, here's how you can download it. If you want to run just a simple standalone cluster, just download it, untar it, and then you could just run it. It's that easy. Obviously, you could also run it through the cloud. We always have some free promotions there. Or you could do it with Docker. You could do it with Kubernetes. All the Helm charts and Kate operators are out there. Pretty straightforward. Before you do anything, just set up your environment. This can be done through REST, can be done through an admin console, can be done through a UI. Very simple to script it up is using the admin command line tool to create your environment where you're going to put your data. Now, what's nice with Pulsar is it's multi-tenant. So I can create tenants for anyone who wants to use the data. These could be different companies, different apps, different groups. However you want to set that up. For today, maybe I'll set up a tenant for the conference. I'll set up some namespaces underneath it, maybe one for this particular one. And I can list them, do what I want. And then underneath there, let me start building up topics. What you'll notice here is this word persistent. This is important because Pulsar also supports non-persistent topics. Most people don't do that, but if you needed to save a little speed, not putting stuff on disk can help you a little bit. Obviously, there's so many benefits of having persistent messages, but maybe these are just, log events that happen 10 million a second. I just need to sample them once in a while. Yeah, don't persist that. That's up to you. Install the Pulsar client. Pretty straightforward. I've got some helpers out there for doing Raspberry Pi, which I've put that on. I don't know. I've got Python plus Pulsar plus Raspberry Pi and like 12 devices here. So I'm heating up my office here with all these little Pis. Pretty straightforward to do. Just install the Pulsar client. Now, depending on your architecture, you may need to build a C++ client first. Again, I've got helpers for that if you need it. But if you're on Mac or most Linux on Intel, you don't need to do anything else. The code is pretty straightforward, depending on your security, which is a lot of security options. You just create a client, create a producer, send a message, and you're ready to go. And then clean up after yourself is always nice. But let's not show all UI. In the open source, there's an open source tool to manage your Pulsar environment called Pulsar Manager. And I can navigate through all the different things that I've created here and see all the topics. Like we said, tenant, namespace, topic. And we can look at different ones, see how many messages are coming through the system. Great way to do simple administration. Same idea as if I'm doing that through Stream Native Cloud. Slightly different UI, but you've got the same things there, the tenants, the namespaces, and the topics. Again, to get to a topic, to keep that, distinct, so you don't have to come up with really long topic names. You've got tenant namespace, as you see from the drop downs. And then under there, you've got your different topics. You can have millions of topics. Obviously, that'll take some storage, and you probably should have some creative naming, so you don't put 100,000 under one namespace. Create as many namespaces or tenants as you want. Obviously, once you start getting into the millions, you better have a good naming convention there, or you will be very lost. Okay, so let's take a look at some code. So this is one of the Raspberry Pis I have running the Python client. And I've got a couple of variations here. So let's take a look at one. Yes, I am using VI. I have other editors, but let's show you right down to the bare metal here. So what do I have to import here? I'm importing over here the Pulsar schema. Up top, I've got Pulsar, and I've got some libraries to do all kinds of random stuff that I'm doing in my actual Python app. So this is my schema. Starts with the word class, weather, and record comes from the Pulsar schema. This is all you need to do. This is so easy to set up a schema. If you saw what you had to do in Java, you would realize why you want to do Python. You set up the types, names of the things you're going to do. Your schema is ready. So if I've never called this topic before, this will use this to build the schema for you. You don't have to handwrite anything. You don't have to write any converters. There's no extra work for you. Okay, so I'm using my own local cluster that I'm running on an old rack server that I got for $300 from Amazon. It is just a regular Ubuntu server. I can connect to that. Since I'm in my office, I don't have security. You should use security. If you're using Extreme Native, it's locked down with security and SSL. Again, depends on what your environment is. So I've created my client, and then I'm going to create my producer for this specific topic. Obviously, everything can be a parameter or an environmental variable or wherever you want to put that. So we set our topic, and this time you saw the schema up there. I'm going to use the JSON schema format, and I'm going to put a couple properties here to tell me where it came from. And here I'm reading some sensors, and I'm doing all that fun stuff I like to do to sensors. And down here, I created an instance of my record, set the variables, make sure they're in the right format and type and rounding or whatever. And then there's my send. I send a partition key. That's that key we mentioned. Again, I'm just generating a unique ID. If you had some kind of other mechanism for creating keys, sure, go with it. Dupes can happen. And this one, we could just run in an infinite loop here, and it'll just keep running. I've got the same thing doing with Avro. As you see here, where I'm printing them out just so we could see the messages, but these are sending these. It's in a loop. It's about 1 a second, and we're getting stuff to weather. This is just one of our topics out there, and you can see it's telling you that it closed the client to this topic, and I can view that topic from wherever I want to look at it. So here is Pi weather, and I can see we've got a couple of messages in there. And if I wanted to, I could do a query on them because we have a schema. We also have the same thing I could do with Avro. I have an Avro version here, not drastically different. You'll see I probably should have pulled the schema out, put it in a separate file. Kind of lazy. I could have done this all in one file, maybe with a parameter to pass in. Very easy to do. Avro schema, that's it. That's the difference. I put it into a different topic because I don't want to mess those two formats up. And I just put this in the weather Avro one. Can make sure that one's working. And we'll just run it to there. Same idea though. Doesn't matter. You know, schema, no schema, different type of schema. Over here, I'm on another Raspberry Pi. Again, if I'm a person, I could show you this. This one, I have different sensors. We'll take a look at this one. Same idea. Different things for my schema. Send it down. Again, pretty straightforward to send things with Python. One of the nice features of why I really recommend using Python, especially for these IoT applications that tend to have all their libraries in Python anyway. So it doesn't make sense. I've tried to do it. I'm like, oh, maybe I'll do it in Go, or maybe I'll do it in Rust or something else. Stick with Python. It's easy. It's got all the libraries, works really fast, has all the features you want. I'm all in on this one. Now in this one, I've got a little runner here because I'm also outputting this to a little screen. It's a very small screen, so I won't try to put the camera on it. So, you know, you might have some extra parameters to set there. Pretty straightforward. You know, however we want to run this. Let's see if we got anything interesting on this box. Again, this one I'm doing NFTs, and this one has a WebSocket producer, which if you've looked at the library for WebSockets before, it's pretty straightforward. So to send a message via WebSockets to Pulsar, I set up my topic. The format's a little different. We've got a web port for REST on Pulsar. For this case, we're doing WebSockets through there. We could do REST messages, however you want to send it. Create my WebSocket connection. Again, if there's security like OAuth or SSL, slightly different here. It's WSS, and you got to have a key or some token. Here, what we do is we have to encode base64 encode the message. That's the payload. So that gets sent over, and then the properties send that over, and then we get the results. Now I could do this with Python, obviously, as we saw the library is very straightforward. I can also do the same thing with JavaScript. So I can communicate to a server here if I didn't time out over here. You might have timed out on my thing. This is a little Python web server I'm running. So this is here. I'm going to use a simple front end web page. And if we look down here, these messages are being fed from WebSockets, but they're not the message up here. This message is sent to the chat2 topic over WebSockets. In Pulsar, there's a Python function running that receives that message, runs sentiment on this over here. Let's see if that thing is positive. Yeah, that thinks it's positive. And this will receive those new messages as they come in and add sentiment on it. So I've got sentiment analysis running over here in this simple function. So as it's received things, I'm running in local runner mode so I could see things as they're happening. Makes it a little easier to debug what's going on. And I could send a lot of the same thing. I could also have 20 other people chatting, sending their messages through there. We can see we've processed 10 messages in the last little bit as we're running. And this is running a very simple, what I call my PyChat, very simple little open source function. A function for Pulsar is very simple, especially for Python. We have, you know, whatever requirements you need. Dependencies you could preload in a directory, makes it a little easier. And the source, it is pretty straightforward. I use that one library, set things up as a class. Any init I might need to do there. Here I'm using Vader sentiment. I've got the process. I get a context. The context from Pulsar lets me have a logger, lets me have access to state, lots of different things I could do with that context. So I get the data, I can get the message ID. I'm not using a schema in this one because setting up schemas from a web page, I didn't really want to do that. I'm kind of lazy. So it just comes in here. Then I use Python to parse out the JSON fields, grab the field, run sentiment on it, create a new JSON message, and that gets returned to whoever this was deployed by. When I deploy it, this is the deploy for that function. Tells me the class, what's my input, where do I log errors to? So that goes to another topic. So you can dynamically handle that. And there's the output. That's that chat result 2. That's what this guy is listening to. So when new messages come in, I can put that is the worst UI ever, Tim. That's negative. What are you gonna do? I'm not a web front end guy. It would be nice to have someone who could clear up my stuff. Pretty straightforward there. So, I mean, you have different ways to get things in, deploy my Pulsar functions. I can run them locally to test them. I can deploy them in a function mesh. I can mix and match with other languages. So I could have maybe one part of an enrichment cycle in Python, one in Go, one in Java. Makes it pretty easy to mix and match. Now, if I want to run Python, since it is just the Pulsar client here is just a regular library, I can run that from a Jupyter notebook or Zeppelin, anywhere I can run standard Python, pretty straightforward. I can run a ton of different, different types of servers here, different ways to send data around, regardless of what you might need to do. Pretty straightforward to do this. Let's get back to the slides for a little bit, and we'll keep an eye on questions, see if people want to see something else. Feel free to drop them in the chat, and we'll answer them at the end, but I'll keep my eye open in case something comes up before then. So you may have authentication, and if you're doing this in the public cloud or in the real world, you really should use security. If you use the Stream Native Cloud, it's using Pulsar plus SSL to make any calls out. And then it will have a couple different authentication methods. OAuth is a pretty standard one, pretty straightforward to do. Set that up, go by your private key or however you want to do it. There's full examples out there. You could try it out. Easy way to get the data in there. We showed you those schemas. This difference between Json and Avro is how it looks when you're looking at the schemas. Pretty straightforward. Code is pretty easy. So if you decide you want to change it, just create another topic. Rebuild it if you don't care about the data. Now, consuming data, that's when things get a little interesting because events can happen constantly. So you have to decide, how do I want to consume the data? Am I just going to grab what's there now and then close? Do I want to run in a loop? We also have a reader API where I could maybe go back some and grab a chunk. You have decisions there. You have your own subscription. So if you want everyone to read at their own pace and get their own set of messages, you set up their subscription type, give it its own name. If you want 1,000 workers to process things as fast as possible, all the same subscription, have that subscription type where it isn't exactly once, and just have these consumers waiting there, little Python apps waiting to get a message, run some work and be done. And you could scale it out to millions of them if you need to. Now, MQTT, very easy way to send messages to Pulsar. Don't have to use any special library. Paho has a great MQTT library for Python. You create the client, log in again. You may have a username, password, all that's supported. And then when you're done, you just publish the message. And you could use the same naming convention of topics. Pretty easy, pretty straightforward to send them. And I've got some slides showing you some in-depth MQTT stuff that's interesting. We showed you the WebSockets. Very easy if you want to use Python now to easily communicate with a web app. But what's cool is if I don't use this WebSocket to get my data in, it doesn't matter. If I get it into Pulsar, I can pull it out with WebSockets, no extra work, no special libraries. It just happens, very straightforward. If I have Kafka apps and I want to use Pulsar, same idea. There's a great library for Kafka. Pretty easy to do. Same idea. Producer send it. If you have security, SSL, all those things can be done as well. And you don't have to know that it's Kafka. You don't have to know it's Pulsar. Use the whatever mechanism you're using, and we'll just get that and be able to pull it out. This is an add-on I could turn on or turn off, depending on, if I want to receive Kafka messages. The more you run, it'll take more RAM. Now, this is a typical application that I'm doing for the thermal. I have an IoT app running in Python on a device, pushes that data into a topic on my Pulsar cluster. It's got a Pulsar function, consumes that, does some enrichment, and then I've got some ML apps that'll read that data. Maybe that's for training, maybe that's for final classification, whatever you happen to do, pretty straightforward to do that. To deploy those functions, I showed you, maybe it was too small on the screen. This is what it is. There's some options here. This will create and deploy it. You can deploy it to function mesh. I can create this in local run mode. So it'll just run and I could see all the logs there. And then when I'm done with it, just shut it down. If you're doing just some learning, development, trying out a process or running a short-term thing, easy way to do it. Again, Pulsar is easy to set up and create a lot of nodes. Can run on something as small as a big Raspberry Pi or say like a Json or any MacBook, Windows, whatever little server you might have, or on a desktop. Pretty straightforward. I've got links to a lot of example code out there that I'm doing for different devices, different use cases. And I've got some in-depth examples of some more advanced Python use cases. If you need to do some, complex things like, do I want to do some readers? Do I want to go back? What happens if I can't send a message? Do I want it sent to a dead letter queue? Do I want it to sit there so someone can consume it? How do you do logging through topics? Lots of options there. If you're interested in Pulsar, sign up for a Slack or watch us on Twitter. We've got newsletters out there. Please contact me. I'm going to go back into the demo, but keep my eye out for any kind of questions out there. If you have any questions or things you're interested in that I didn't cover, because I kept this pretty high level, so I don't dive into the weeds of Pulsar, because you don't need to do that to send things. It is as simple as, using an existing library you have, make sure it points to the right port, and you've got it. In Pulsar, we like to acknowledge the message so that that it's read. So if it's non-persistent, it can go away. If you've got a time span of how long things live, that'll let me know that's already been consumed and we're all good. So that can go away. Or you could keep this data forever. Like I'm stopping this here. I stopped my little function there. If I wanted to look at, say, Pulsar SQL to look at some of the data, it's very easy here. I'm going to select it out of Pulsar because Presto can connect to many kind of databases or backends. Go to my tenant namespace, and we'll look at this one specific topic that I'm feeding from Python, and it looks like a table. If I'm curious to see what that looked like, I could just do a describe on it and get what that table looks like. Get all the fields, because this is coming right from the schema. Makes it pretty straightforward, easy to see. Now, there's a couple of things that you may have not set up. Things like partition. I can partition topics if you're doing something that's Kafka style or to improve performance for events. Easy to do, and you'll get back that partition so you know where that data is. You get an event time. That's when the event occurred. You get the publish time of when the event was published into Pulsar. You got your message ID, sequence ID, so you know where this row is, who produced it, the key, those sort of things. And those are values that I can look at, and I could see, who did what when. And they have some funky little things there because they are special values. These are not ones that you created. These are ones that were produced by Pulsar. These are internal ones, but they can come in handy for queries. Did I spell something wrong? No, maybe I should put a real value there too. How about UUID in memory? Oh, I forgot the catalog. You could also do this with a tool like dbeaver or any of the database tools, because it has a standard JDBC connection there. So now that I've got the data into Pulsar with the help of Spark SQL or Flink SQL or Presto Trino, I could access that data in any way I want. And I know that it's in this format that we looked at. Pretty straightforward there. It's an easy way to access your data. Just another way to do it. You can run a Spark job, Flink job, or any kind of coding there. Not difficult to do that. And I get full access to that. Now I can put additional security and permissions on each topic if I needed to do that. Lots of different things I could do. I create tokens for security. I can see the different namespaces. I can have multiple clusters. And on top of that, I can have one instance with multiple clusters on it. Depends on how you're setting up your environment, how you want to do that. Pretty straightforward. We have a few minutes left, so maybe I'll try to dive into the Python code. Again, it is very straightforward code. It is not difficult to do that. It is perhaps the easiest part of your coding. So you have any Python app, you could very easily just augment it by adding something like MQTT. So here I have an older version of my app, and this was running, and I didn't think I needed a different system. So I was just logging it to a file. And then I decided, hey, I could do MQTT and just publish it that way. Or, I could read a log file before I had messaging. I put in a log file and have someone read the log file, however messages came through with that way. Not the easiest, but here sending it through MQTT, 2 lines, but that's going to Pulsar. With the new one, I have it so it just does Python through Pulsar, which again, I think is cleaner and a little easier, very easy to do. You don't need to change much in your code. If you want a record, you see, we just apply it to a record, or I could have just sent whatever text I had before, whether that's just JSON or a binary text file, Avro, Parquet. Not very difficult, regardless of what you're doing. Now, when we're trying to get messages back, clearly I can write an application to do that. But I can also consume things in a very easy manner, especially when you're trying to test things. I could just use the Pulsar client to consume them. Pretty simple way to be able to consume different messages, and a great way to debug things. And because I can give them its own name, it doesn't really affect things. So let's just pick one. How about thermal data? So let's run, let's see where thermal goes to. And we'll grab that topic, and I'll just be able to read it and show you how easy that is for you to get your data from wherever it is to somewhere else without being on the same machine, being on the same network, even knowing what's too much about that data. And we'll grab that data as it's coming in. And We'll see if that data is starting to send here. I see some records over there. Here's the records coming in, and I can see the key. They're nicely formatted because those are with a topic. Again, I could run a Presto SQL and get the same data. I could write a very simple consumer in Python to do it, or in another language. Again, a nice way to bridge between different systems, between different languages, without having, too much heavy lifting. To add Pulsar to an existing Python app is one import and a couple of lines, depending on your security setup that you want to do. Not the most difficult thing in the world. Maybe I should mention subscription modes. I kind of glossed over it. Oh, are we getting low?
Yep, we are at time.
Oh,
Thanks, Tim.
okay.